Okay, so in this tutorial we are tasked with finding the minimum value of this function sine x to the fourth plus cosine x to the fourth. Okay, so you have to find the minimum, which is we want to find the lowest possible value. Okay, but okay, so here's how you could approach this problem. Okay, so sine x to the fourth plus cosine x to the fourth can be written as a difference of two squares. So it can be written as a sum of two squares. Okay, so you can expand this thing to be it's the same as sine squared x plus cosine squared x all squared. Okay, so when you square this thing, sine squared x all squared, this will give you a sine x, then you multiply the exponent, so the sine x to the fourth, so it will give us this term. Then we square cosine x. Okay, we square cosine x. When we square cosine x, this will give us cosine x to the fourth. Okay, but since we're squaring a binomial, we have an additional third term. Okay, so the third term is the product. So it's the product of sine squared x plus cosine squared x plus 2 times 2. Okay, because when you square a binomial, okay, you square the first term, which means we square sine squared x, we get sine x to the fourth. We square the second term, which is cosine squared x. This will give us cosine x to the fourth. Then now we multiply everything we have in this expression, sine squared x times cosine squared x times 2. Okay, which means we will have an additional third term. Okay, we'll have this term 2 sine squared x times cosine squared x. Okay, now when we add this term to this expression is no longer equal to this expression. Okay, which means we need to subtract it. Okay, so we need to remove this term. Okay, so to maintain the equality of these two equations, so we need to subtract this term 2 sine squared x times cosine squared x. Okay, now we can recognize this identity. Sine squared x plus cosine squared x is a square identity. This is equal to 1. Then you have the square, so squaring 1 will not make any effect. Now you have 1. Okay, now you have 2 sine x cosine squared x. Okay, so we have this identity. This is similar to this identity 2 sine. Okay, there is no square. I'm making a mistake. So it's 2 sine x cosine x. This is same as sine 2x. Okay, 2 sine x times cosine x is equal to sine 2x. But now we have the square. We have sine x squared, we have cosine x squared. So the only way we could get sine x squared is if the sine x is being multiplied by another sine x, which means this expression is being multiplied by sine x. This is what gives us sine squared x. And now what gives us cosine squared x is if we multiply this expression by another cosine x. So now we have 2 sine x cosine x times sine x times cosine x. This will give you this expression, which is 2 sine squared x times cosine squared x, which is no longer equal to this identity. Okay, so sine x cosine x is not equal to sine 2x, but is rather half of sine. So this thing is half sine 2x. Okay, which means this term is equal to the product of sine 2x and half sine 2x. Okay, so this will give us half sine 2x squared. Okay, this is the term. Okay, so now you have 1 squared minus this term minus half sine squared 2x. Okay, so now we want to find the minimum of this thing, and we are separating two things. If you are separating two things and you want to find the minimum, you need to make sure that the thing that you're separating must be large. Okay, if I have 10, I want to find the minimum value, the lowest possible value. I must separate something which is very large. Okay, so let's say I could get something which is less. Okay, so now you look at the part of the function which is changing. The part which is changing is this part sine squared 2x. Okay, this is the part which is variable. Okay, so this is the part that is changing. This is the part we can control. Okay, so we're minusing, so we need this part to be at maximum. Okay, so we need to maximize sine x in order to get the minimum of this expression, sine squared 2x. We need this part to be at maximum. Okay, sine 2x all squared is same as sine 2x. Sine squared 2x is the same as sine 2x all squared. Okay, so the inside part, which is this function sine 2x, is a trigonometric function. It ranges between, okay, it ranges between, the coefficient is 1, so it ranges between, we have sine 2x which ranges between 1 and negative 1. Okay, this is the range of sine, this is the range of sine 2x. Okay, this is the range of sine 2x. Okay, this is where sine 2x is at minimum. This is where sine 2x is at maximum. Okay, this is the maximum value of sine 2x. Okay, so now we want to find the minimum value. You want to find the minimum value of this expression. Okay, you want to find the minimum value, the lowest. Okay, so 1 squared is 1 minus half. Okay, minus half. Okay, so when you square this thing, okay, sine squared 2x ranges between sine squared 2x, okay, sine 2x ranges between negative 1 and 1. Okay, now what will the range of sine 2x be? Sine 2x all squared be? Okay, so sine 2x all squared will range between 0 and sine squared 2x. So the range between 0 and 1, because when you square a number, it cannot be negative. Okay, so it can either be 0 or above 0. Okay, so when you square this thing, it can either be 0 or above 0. Okay, so now this is the range of sine squared 2x. Okay, so this is the minimum and this is the maximum. Okay, it's 0. Okay, so you have the minimum of sine squared 2x, the minimum of that function is 0 and the maximum is 1. Okay, but because we want this expression to be the minimum, at the minimum value, to be at the lowest value. Okay, so we need this part we are separating to be large, because this is how we can get something which is small. If we are separating something which is large, then overall our expression will be at minimum. Okay, which means we need to substitute the maximum of sine squared 2x. We need this part sine squared 2x to be large. Okay, to get the minimum of this expression. So it's 1 minus half times 1. This will give you 1 over 2. Okay, so this is the maximum value. Okay, this is the maximum value.